Right, we are doing 1.2 notes, continuing on with chapter 1 now that you're familiar with some of the vocabulary, and I apologize for my nasally voice. My daughter gave me a cold. So, starting with this warm-up, we are just reviewing systems here. We are given that angle TRS is a straight angle. And remember, a straight angle means it's equal to 180 degrees. And we're told that TRX is a right angle, which means it's equal to 90 degrees. And if TRS is a straight angle and 180 degrees, I can infer that XRS is also a right angle because 180 minus 90 equals 80. Or sorry, 180 minus 90 equals 90. So TRS is equal to 2x plus 5y, and XRS is equal to 3x plus 3y. So let's write this system. TRS, that's our one that's equal to 180. And XRS, that one's equal to 90. All right, and this is where you would determine if you wanted to use elimination or substitution, and I'm going to go ahead and just use elimination. I want to cancel my x's, so my least common multiple between 2 and 3 is going to be 6, and one of them needs to be positive, one of them needs to be negative. So I'm going to multiply this top equation by -3, and my bottom equation by +2. For my top equation, when I distribute that -3, I get -6x minus 15y is equal to 180 times 3 is 540, so that's -540. Then I get, with my second equation, 6x plus 6y is equal to 180. So now I add my equations, my x's cancel, I end up with minus 9y is equal to -360. Divide by minus 9 on both sides, and y is equal to +40. So there's our y. Now I have to solve for x by plugging back in, and I'm going to use one of my original equations, and it doesn't matter which one, I'm just going to go with the top one. 2x plus 5 times 40 is equal to 180. So that is 2x plus 200 is equal to 180. Subtract that 200. 2x is equal to -20. So x is -10. And if I'm going to give my answer as an ordered pair, that would be -10, 40. So just a review of systems here. Now everything else you should be familiar with. We talked about acute, right, obtuse, and straight angles in class already, as well as tick marks. Remember, when we have matching tick marks, that means that I have congruent segments or angles. So here, just to name a few, angle A and angle D have matching tick marks, so they are congruent. Segment BC and EF have matching tick marks, those little circles, so those are congruent segments. So anywhere that we have matching tick marks, that indicates either congruent segments or congruent angles. All right, let's flip over to the back side. And I'm pretty sure I have a typo on this, I apologize. So in this diagram, angle DEG is 80 degrees, so that whole angle is 80 degrees. DEF is 50, so I'm going to label that as 50. HJK is 120. That's supposed to be HJM, I apologize. Angle HJM is 120. HJK is 90. Okay? So this whole angle is 80, and this whole angle is 120. What conclusion can be drawn about FEG and KJM? Well, first of all, I know that DEG is the sum of angle DEF and FEG. So that's equal to angle DEF plus angle FEG, which means that it's 80 is equal to 50 plus whatever the angle of FEG is, whatever that measure is. And on the other side, angle HJM is equal to the sum of angle HJK plus angle KJM. So that's 120 would be equal to 90 plus whatever the angle of KJM is. So I can solve this equation for the measure of FEG by subtracting 50 on both sides. And I find that the measure of angle FEG is 30. And same thing over here, if I want to solve for the measure of KJM, I can subtract 90 on both sides. And I get that KJM is also 30 degrees. So the conclusion I can draw is that angle FEG is congruent to angle KJM because they have the same measure. They both are 30 degrees. All right. Number 2, I want to find the measure of angle 1 if I'm told ABC is a right angle. So that means that angle 1 plus angle 2 gives me 90 degrees. And we're given the expressions for angle 1 and angle 2. So I'm going to plug in 3x plus 4 for angle 1 and x plus 6 for angle 2. Set that equal to 90. And now I can solve this algebraically for x. So I'm going to combine my like terms. 3x plus x gives me 4x. 4 and 6 gives me 10. And now I just have a two-step equation. I'm going to move that 10 over, and I'm running out of room, so I'm going to write it here. So 4x equals 80, which means x is equal to 20. Now I'm not done though. We were asked to find the measure of angle 1, so I need to now plug in this value of x to my expression for angle 1. So that's going to be 3 times 20 plus 4, and that would be 64 degrees. Excuse me. Now number 3, we're told if angle B is acute, we have two parts here. The first one is what are the restrictions on the measure of angle B? So that means what possible values does the measure of angle B have to be between to meet these specifications we've been given? And we're going to represent this with inequality notation. So remember, an acute angle is between 0 and 90 degrees. So for part A, if we're between 0 and 90 degrees for an acute angle, the measure of angle B has to be between 0 and 90 degrees. So those are the restrictions on the measure of angle B. Now part B asks for the restrictions on x. Now we're told that this measure of angle B can be represented with the expression 2x plus 14. So to do part B, we are going to substitute in this expression in place of the measure of angle B, come on, focus, that we made here in part A. Come on. I don't know why that thing was having such a hard time focusing. So we are just going to substitute this expression in place of the measure of angle B from part A. So 0 is less than 2x plus 14 is less than 90. So now we're going to be solving this similar to an algebraic equation. However, what we do in the middle, we have to do on both sides of our inequality. So if I'm going to solve for x and get x by itself, first I subtract 14, and I have to do that on both sides. So we're going to get negative 14, that's a 4, between 2x, between 90 minus 14 is 76. And then the last thing I need to do to get x by itself is divide by 2. And I have to also do that on both sides of my inequality. So we get that x has to be between negative 7 and positive 38. Those are the restrictions on x. In order for my angle to satisfy the requirement of being acute, x has to be between these two numbers. Otherwise, the measure of my angle will be smaller than 0 or bigger than 90. And last but not least, we've got another good intersection and union problem. You should be familiar with this from your homework assignment where you just had to watch the video. And to make this easier to see, I'm going to color code my drawings here. So, starting with part A, we are looking for the intersection of segment AE and segment HE. So remember, intersection is where they meet, where they overlap. And the place where they overlap is segment HE, this entire segment and all the points in between it. So segment HE. Part B is asking me to find the union of segment AE and segment HE. So the union is all the parts together. We already have that highlighted here. And so all the parts together is going to be this segment A to E and all of the infinite points between. Next, part C is asking us to find the intersection of ray HT. So that would be ray HT here in green, all the way off to infinity, and ray TE. And I'm going to draw that here in yellow. So TE starts at T and goes off to infinity that way. So the intersection, where they overlap, is going to be from here to here. HE, segment HE. The intersection. Then part D wants me to find the intersection of ML, here's ML, and LE. And the only place where they overlap and intersect is at point L. Then on E, we're looking for the union of ray EM. I'm going to do yellow so you can see it better. EM, it's going that way along here, EM, and ET. ET is going that way. Now remember from the definition of an angle as well as your homework assignment in the video, when we have the union of two rays, it's all of this area in between. So that is going to be angle MET. All of this space in between. Remember, the definition of an angle is where two rays meet. And lastly, ray AE. Ray AE is going this way. And ray TH, the union. So the union is going to be the combination of those two rays, and because they are going along the same line in opposite directions, it's going to be line AT. It goes on and on forever in both directions. And that will conclude our 1.2 notes.